Hello, in this video I will do a quiz on related rate word problem. So on this quiz we're doing a ladder problem. A ladder is 20 feet long, is leaning against the wall of a house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. So there's a two-part question. So part A says, how fast is the top of the ladder moving? So how fast is the speed? Is the top of the ladder moving down the wall when the base of the ladder is 70 feet from the house? And then part B says, consider the triangle formed by the house, ladder, and ground. Find the rate, so that's a speed, at which the area of the triangle, so the area of the triangle, which is base times height over 2, is changing when the base of the ladder is 7 feet from the house. Okay, so part A, how fast the top of the ladder is moving down the wall. So let's do part A. The part A says, how fast is the top of the ladder moving down the wall when the base of the ladder is 75 feet from the house? But let's draw our image. So here we have a house. Right, here's the door. Here's some windows. Okay, and then here we have a ladder. That's a total length of 25 feet. It does not extend, it's just 25 feet. And here's the base of the ladder. And then, so when this ladder falls down, the height is changing, so the rate should be in the negative direction. So when this ladder falls down to the ground, the speed or the rate of is going negative because it's eventually slowing down. So let's draw this triangle right here. This forms a right triangle, right? Here's the ladder. It's a total length of 25 feet. And here's the base of the ladder and then the height. Uh, so we'll probably have to use the Pythagorean theorem because we're not trying to find any missing side. We're not trying to find any missing like angles. So I think we're trying to find missing side lengths. So we're going to do Pythagorean. So Pythagorean is a squared plus b squared equals c squared. But in our case, our leg could be expressed as b squared, and then my height could be expressed as h squared. And then my hypotenuse is 25 feet squared. Okay, so now we have to take the derivative implicitly in respect to time. So start with b. What's the derivative of b squared in respect to time? Well, the derivative of just regular b squared is 2b. And then you do have to add the db dt. And then the same thing with h squared. What is the derivative of h squared in respect to time? Well, the derivative of just regular h squared is 2h. And then you have to add the dh dt, right? Equals. And then the derivative of a constant 25 squared is just 0. Uh, Now, what are we trying to find? We are trying to find how fast is the top of the ladder moving down when, so they're asking for the speed. So um, are we trying to find dB dt or dH dt? Yeah, I think we're trying to find dH dt, and then we actually have one rate already. The base of the ladder of the base of the ladder is pulled away from the wall at a rate of 2 feet per second. So I think we have the dB dt. Yes, we do. We have the dB dt, which is 2 feet per second. Now what we're trying to do is find dH dt. Okay, so, and believe it or not, we also have one more thing. I made a mistake right here. This should be not 75 feet. This should be 7 feet. So we have a length, or I guess in our case, our B would be 7 feet. So our B is 7 feet. So now we have a better chance of finding dH dt. So maybe first I would just get rid of this constant 2 by dividing all sides by 2, right? Including the 0. So now we have B dB dt plus H dH dt, and then on the right it's 0. So our goal is to find dH dt, and we have our base. So our base is 7 feet times dB dt is 2 feet per second plus h. Do we know what the height is? Yes, we do. No, we have to find it. That wasn't given, so we have to find it with the given information. So we have to draw a triangle again. So this is still 25, and then this base, if this base is 7, now we can find the height by applying Pythagorean theorem, right? So it would be h squared plus 7 squared equals 25 squared. So that's h squared plus 49, and then 25 squared is 625. Solve for h, so I would subtract 49 from both sides. So I have h squared equals to 625 minus 49 is 576. Solve for h. H is 24. And I'm going to use the positive 24, right? Good. So now we have the height, which is 24 feet. And then we have dH dt. That's what we want to find. Equals to 0. So let's clean this up a bit. 7 feet times 2 feet, that is 14 feet squared per second plus 24 feet dH dt is 0. And then go ahead and continue solving for dH dt by subtracting this 14 feet squared. And it's okay to have a negative. We said that negatives are fine because it's going down. So I'm going to subtract 14 feet squared per second. So let's cancel. So you're left with 24 feet dH dt equals to negative 14 feet per second. And then solve for dH dt. So I'm going to divide this by 24 feet. And I'm glad I kept my units because now the feet, one of the feet will cancel until you're left with feet per second. So that's right. So my final answer is dH dt. So what's negative 14? So negative 14 over 24 can be reduced by at least 2. That would be, the final answer will be negative 7 feet per second. Okay, so that is my dH dt. Okay, so that was part A. Now part B says, consider the triangle formed by the house ladder and ground. Find the rate at which the area of the triangle is changing from the base of the ladder 7 feet from the house. So we can use this, kind of like use the answers from the same problem. So if we, let's go back to this right triangle right here. So part B. So we have that right triangle. This is 25. This is B, and then this is H. So this time, we're not going to use Pythagorean theorem. They're asking related to area of a triangle. So area of a triangle is base times height over 2. And this time, part B, they're saying find the rate at which the area of the triangle is changing at the base. When the base of the ladder is 7 feet from the house. So the base is, that was given out 7 feet. And then what are we trying to find? We are trying to find dA dt. And we already have dB dt. That was 2 feet per second. And we also have dH dt, which is negative 7 feet over 12 seconds. Okay, so let's see here. So if we use the formula, A equals 1/2, and then my base is, oh, darn. What we have to do, we have to apply. So if we're going to take the derivative, yeah, let's take the derivative implicitly. So on the left side, what is the derivative of A or 1A? It's dA dt. And then on the right, it's 1/2. And then it's base times H prime. So we have to take this, we have to use the product rule, and we have to be careful because we have to take it in respect to time. So what is the product rule? It is F prime G plus G prime of F. So I believe my F will be B and my G would be H, right? So F is B and G is H. So F prime in respect to time would be, the derivative of B is 1, and then in respect to time, it would be dB dt. And then G prime, the derivative of H is 1, and then in respect to time would be dH dt. So this would be dA dt equals to 1/2. And then if you apply the product rule, F prime is 1 dB dt. G is H plus G prime, which is 1 dH dt. And then F is B. Okay, so we kind of clean this up. This would be 1/2. And what did we say dB dt is? dB dt is 2 feet per second. What is my height? It was 24 feet, right? I think that was given. Yeah, that was given. My height is 24 feet. Plus my dH dt that was given, negative 7 feet per second. Or negative 7 over 12 feet per second. And then the base was 7 feet that was given. Okay, now let's just clean this up. So this would be dA dt. One half, and then 24 times 2, that is 48 feet per second, minus negative 7 times 7 is negative 49 feet per 12 seconds. And if you kind of clean this up, they're in the same unit. So when you clean it up and times it by 1/2, you should get 527 feet square per second. No, not feet square, it's just feet, right? So my dA dt is 527 feet per second. Okay, so on part B, we kind of have we had an advantage because we could have used the answer from part A to help us, right? Okay, that wraps up for this quiz on related rates.